Hello, Mitch Tweedy here with Compass Data, CompassDrone, showing you how to plan a corridor mission in UGCS, Universal Ground Control Software. We were flying the DJI Matrice 600 and the Regal Minivux for this one. Download and install the current version of UGCS from their website. We do recommend staying current with all the Windows and Android bugs these days. It's best to stay current. So first things first, let's go to map options, map layers, and 2D objects. This is where we're at our corridor KML. So this just creates a name, and then you actually upload the KML. So hopefully your customer will send you a KML. If not, you can draw it from hand here. But you create a layer, upload a KML to it, and then move it over to the enabled side. And you can say focus and UGCS, wherever that KML exists in the world will go find it for you. It loves to come in tilted, so it's good to double click the north arrow anytime you get lost. Just double click north. So to move around the map, I'm using the left mouse button, scroll wheel, and then to tilt it, I'm using the right mouse button. But this is the alignment the customer wants me to fly, Class G airspace, and these are bigger transmission towers. So it's important to understand whatever your height is above the ground, that's also, you're getting double that once the LiDAR hits the ground. So we're flying a Regal Minivux, and it's getting good data, 45 degrees either side of the sensor. So if we're 400 feet high, this distance is 400 feet, and so is this distance. So total of 800-foot swath. But let's say the customer wanted greater detail and to capture the very tiny top wires. That's where we would bring it down lower. So even the highest transmission towers in the US are really only 120 feet or roughly 40 meters high. So power lines are commonly captured at like 60, 70 meters instead of 400, but depends on what the customer's objective is. So in this instance, they want to run another power line in this congested corridor. So if they didn't care about actual structures and conductor wires, we could just fly this at 400 feet and get an 800 feet swath with, or actually we could space it out to 1600 feet if we wanted to. And that's only if they were concerned with the ground underneath this corridor. But if they wanted actual structures and wires, conductors on the structures, then we would bring it down probably to 60 meters. And then depends on how wide the customer wants the corridor. That would determine the distance between our two scan lines. So definitely don't want to take off under the power lines. There is a nice takeoff location there, but we're sandwiched in between power lines. So I would talk to some landowners, or most power line companies have a right of way, 120 feet either side of the power line. But we will just contact this guy, get permission to launch and land in his driveway. It's nice to be in the center of the corridor, but this will work. They will contact. Yeah, this should be enough room. So I plan to take off right here. I'm gonna add a new route. I like corridor 1 or whatever you like. Grab the airframe that you're going to use. And you know, you don't want the drone to drop altitude, hit the power lines when it returns to home. So this should be higher than the tallest tower. If you get a 120-foot tall tower, definitely, you know, 60s safe, 80s safer. Just depends on conditions out there. And then the maximum altitude above ground is important. If this power line runs up a 200-meter hill, you need your flight height, plus you got to let UGCS terrain follow up that hill. So this would actually have to be 260 meters to account for the flight height and any elevation change from the takeoff location. And in practicality, the GPS isn't that accurate. I would actually, if I wanted a 60-foot flight height up a 200-meter hill, I would buffer that up to 280, 300 meters. I'm still legal. I'm still 400 feet from the ground, but I'm giving UGCS the room to climb up that hill and definitely have it return to home if you lose link to the remote controller. Okay. If you end up, I've done some corridors in residential areas, and it was just safer to walk along with it. You could actually slow this drone down to 2 or 3 meters per second and walk with it. That way there's never any non-participants underneath of you because you're walking underneath of it. That would capture some really dense LiDAR. 50 meters, 50 points per square meter is probably good enough for most applications, and that can be achieved at 4 or 5 meters per second. You definitely want smooth adaptive bank turns. The stop and turn can whack your IMU and cause it to like seize up and not log data. So definitely adaptive. Some customers, I'm gonna grab a waypoint and drop one there by holding shift. Some customers like to program a pre-dynamic, meaning the drone will fly here, turn right, turn left, figure 8 pre-dynamic. That's to wake up the IMU and calibrate it. But we like to spin it manually. Let me pull up a YouTube video. Just using the remote controller, the pilot manually takes it off, and as it's ascending, he or she spins it 360 degrees right, 360 degrees left, and then pushes the takeoff button in UGCS, and UGCS goes and takes care of it. So that's why we just use a single waypoint for our takeoff. And I've just standardized on, if I'm gonna take off right here, I'm gonna put that first waypoint directly north. So I spin the drone. When I get done spinning and ascending, it's gonna be facing north. It's gonna proceed to this first waypoint, and then it's gonna go to work. The first 40 seconds of data with our system is junk. So I'm gonna have it loiter, not over anybody's house or anything, but just go loiter and kind of get in line with the project. And then I like to, these are all just waypoints again. I like to do like a double waypoint. That kind of tells me to start logging. And I can just use waypoints to say like, hey, go up here. Then I'll stop logging, do a nice little smooth turn. It's got one bad waypoint. We'll investigate that later. That would work. It's not really terrain following because it only has the elevations wherever you click on the map. So this is one way to do it. Let's investigate what happened here. Oh yeah, you can see for some reason it forgot some elevations. So I would fix that over here. Altitude, click on the waypoint. It's having trouble for some reason. We went from 60 down to 16. So those were just examples, and I would go back and fix all the altitudes, but I actually want to show you a different way to program. So I'm just going to click delete, delete, delete. Yeah, let's say we're going to capture this at 60 meters, 6 times 3, roughly 180 feet. That'll get us good data on the structures and also the wires. I'm going to hold down shift, and burn some junk data out here, and then get her turned. And you can do an area scan, a very thin area scan. Again, speed equals density. We'll keep the flight height at 60 meters. And we'll draw, be generous, overfly it for sure. And UGCS says at a 60-meter height, 90-meter side distance, I only need one line. This just depends on the swath that the customer wants. 300 feet is typical, so that's like 100 meters. I think a down and back would do it. So we're getting 60 meters either side of this green line and getting great data on these conductors. So that meets the customer's 300-foot spec. UGCS does have some better corridor tools. This is just how I taught myself to do it. So I want 2 lines this way and that. And then I want to turn using waypoints. And same thing here. I could use this area scan, or I can just use waypoints. I guess I don't want the drone just hanging out over the road. It's a rural road, unlikely that I would be over non-participants, but it's just unnecessary risk. So I'm gonna use waypoints. I'm actually gonna start logging way back here. That way this line calibrates those two. But I'll program it to fly. So if there's a house or just something that's a little risky to fly over, you can use these waypoints to avoid it. And we'll stop logging. We'll come down here and turn. And square that up, make it pretty. No sharp angles that would whack the IME. Not bad. And these two, because they cross each other, would help in the calibration of the LiDAR. Let's look at the time of this. And you do that by coming up here to the gears and say show elevation. And UGC estimates it would capture those in 13 minutes, but we still got to come home and land. So I'll do one more waypoint. I'm going to click on this guy, make sure, yeah. If I were to click here, it'd add like a weird waypoint in the middle of stuff, but this is my last waypoint. This 2 waypoints near each other kind of tells me to stop logging. And I'll make a nice smooth turn. And I do want the landing in case I lose link to the remote controller. Yeah, right here in the middle of the driveway is a pretty safe spot. In case the pilot passes out or in case the drone loses link to the controller, it's great to have a waypoint, and that gets transmitted to the drone. And even if you lose link, you can still come home and land here. So this whole thing is for 15 minutes. That's ideal. I get 15 minutes out of WB-47s and 20 minutes out of brand new 48s, and then they really start to degrade after a year or two. So you just got to label your batteries, Alpha, Bravo, Charlie, and just note how much flight time you're getting out of them. Last but not least, the logging. For this, I would probably log each line as its own file. So drone would take off here, kind of warm up, turn, and then it starts here. So I would kick the LiDAR on right here. There's a 2-second delay in the switch. So I don't want to kick it on up here where the corridor is. I want to kick it on 4 seconds before the corridor, let it log. Then here I'd set the switch from logging back to working. And again, 2-second delay. So you want to shut it off after it captures your area, but 2 seconds before it turns. So you're not capturing the spray data. And then turn it on 2 seconds before it gets back to the area. Let her come here, switch from logging back to the middle of working. So you're not logging this junk. And again, logging. And just keep in mind that 2-second delay. Logging, back to working, let it turn, and then logging with definitely a 2-second buffer or more. Let it come across, calibrate these two, and then 2 seconds before she turns, that's where you set it back to working. So this would be ready to fly. All you would need to do is get this laptop and the drone on the same Wi-Fi network. You would start seeing telemetry right here, and then you definitely will make sure you're in manual mode. If you're in auto mode, it would take off at some point during the upload of the flight plan. That's very dangerous. Don't do that. Stick with manual mode, in which case you'll just hit upload. It'll upload the flight plan safely, and then we do that manual launch. So hopefully this was helpful. Mitch Tweedy with Compass Data.